Hello everyone and welcome back to Arctic Retro. So in the last episode I left you off with this Commodore C64C that was not working properly, and I didn't have the time to fix it in that video, but now it's another video, and if I fixed it or not, you really have to see this video to figure out. So let's get right on with it then. Now, before I begin, I just want to take another look at this beautiful motherboard now that it's been cleaned up. And it is a 254-66, as I mentioned in the previous video, and it is kind of a special edition. It is the Commodore 64C Rev 3B. Or B3. So this was apparently the last revision of the longboards for the Commodore 64C, and there's a couple of special things here. It has this 6581 R4AR, which is considered to be the best version of the SID chip, and it also has the very sought after 6569 R5 that has a lot of improvements compared to the earlier VIC-2 chips, and it also has only 2 RAM chips, but it doesn't have that combined chip on the later Commodore 64C, that large PLA and memory management unit chip. It is still the regular old PLA chip in this one. And the keyboard is also kind of special. It has the keys where the symbols are printed on front of the key and not on the top as in the cost-reduced later models. This video is sponsored by PCBWay, and I just want to say thanks to them for supporting my channel. As a hobbyist, I often find myself in the need of some PCBs for various projects. And of course, PCBWay is my favorite PCB manufacturer. Not only do they provide prototypes PCBs for reasonable prices and with quite amazing shipping times, they can also provide you with other hobbyist needs like advanced PCBs, PCB assembly, SMD stencil, CNC machining and 3D printing, and various other products and capabilities. Also check out their shared project site where you can find a lot of ready-made designs for PCBs. So go ahead and visit PCBWay.com to check out their services. So what can be wrong? We found out that the diagnostics cartridge said there was fault with both the CIA chips, but I swapped them and I inserted a known working one, and it's still the same. So probably it isn't anything with the CIA chips themselves, but some of the logic chips around perhaps. And the fault was on the user port and the serial port. There was also reported a fault with the cassette, and that is an entirely different circuit. The cassette is controlled by this circuitry here, I think this transistor, and also it's directly connected to the CPU, so hopefully it's nothing wrong with the CPU, but I'll come back to that fault later. I found the schematics for this particular board on simmers.net, however it's a very poor quality. It's almost impossible to read the text, the labels. However, I was looking for what could be connecting the CIA chips. This is the 2 CIA chips. What is connecting them to the user port and the serial port up here, and yeah, many lines go directly to the chip. This is U1, but as we can see, the serial port goes down here, and it actually connects to this U8, which is a 7406, and that same chip is also used for one of the lines of the user port. So yes, maybe there's something wrong with that chip. So I checked all the signals in the previous video and they all looked good, at least the pins that had some kind of signal on them. Some of the pins were obviously low. I think my next step is to check out this chip. This is U8, it's 7406. So I'm going to desolder this one and actually test it in my chip tester. Yeah, as you can see now, it says U1 and 2 is bad. I'm going to check the signals on U8, the 7406, see if we see anything suspicious there. So this is a 7406 inverter chip, and yeah, it has 6 inverter gates, and that means for each signal in we should have the opposite signal out. So let's see, in the first inverter it's a low, then the next should be high. Yes, and then we have number 2, it's a clock signal, and the next should be the opposite clock signal, the inverse, looks like it. And the next one has a low input and should have a high output, it has. Then number 4, it's high and it should have a low output, it has. The next is low, it should have a high output, it doesn't. So gate number 3, so gate number 4, low input should have a high output, it has. Gate number 4, it has a high input and a low, yes, low output, that's correct. Gate number 6, it has a low input, should have a high output. No, it doesn't. So the last inverter gate there seems not to be working. So checking, input is low, output is also low, so maybe that's the fault. So all these 3 gates here worked correctly. The 2 first on the right side was correct, but the last one here, pin 9 and 8, we had a low input and a low output. That's not correct. I'm not really sure if this gate is even used. I'm gonna check the schematics. Now I just tested again and it seems like the last gate is correct as well. I probably had bad contact first. See here, it goes high when input is low. So that chip seems to work fine then. So what can it be? Okay, I think I got some results now. While the diagnostics cartridge has been running, I have been probing these signals here that goes out, attention out, clock out, data out, and I can actually see while the diagnostics test is testing the serial and stuff, there's actually signals here. So as I was starting about checking here, I can see when this goes high, this pin 13 on U8 also goes high. However, pin 12 does not change. So my initial testing of this chip showed that it had opposite signals, but while this signal changes, pin 12 signal does not change. So definitely that's make me think that that chip is bad, because at the same time if I check clock and data in here, I see nothing. Even if you have something out, you never get anything in. And while I initially thought that the cassette was not affected by the CIA chip, but that is not correct. The cassette read line here, it actually is shared with the same SRQ in line for the serial bus, and that one cassette read here, it goes to U1 CIA 1. So I think my best next option here is to desolder this chip and test it. It might be a dead end, but I suspect this is bad. Hopefully it is. So I'm gonna desolder it with some flux. You can see here why some of these chips are incredibly hard to desolder. You see all the legs, they are very short and they have been cut, and they also have been bent to the side on the other side, so sits there very good. But I think I did it without any damages. Soldering in a socket. So what can this Retro Chip Tester Pro tell us about this old 7406 Logic 7406 inverter? Oh, yes. As suspected, chip failed. I'm gonna test and move it around a few times. It might not sit nicely in the socket. Let's see. Nope, it fails. And here's a brand new one. Let's test that one then. Oops, it failed too. No, that passed. Okay. Chip okay. Not really sure about this one. It has short legs. Maybe it's not. No. It says pass 1 and pass 2 failed. I deem this little 7406 inverter chip as bad. So let's see, did that fix our problems? Did it make it worse? I get nothing now. Well, maybe that's because I didn't connect the power. Okay, fingers crossed. Oh no. Still the same. Oh well, that was at least a shot in the dark, but it didn't work. But I mean, that chip was faulty. At least I can't test it. But still, what I don't understand is when pin 13 goes low, like it is now, pin 12 should then be high because it's an inverter, but it isn't high. Now they're both same, they are both low. But then when the input on pin 13 goes high, pin 12 stays low. So then it's correct. So I don't understand that. Is there some short or something somewhere that shortens that pin 12 to ground? I need to hunt for that. This is kind of strange. I check short to ground and yeah, pin 12 and 13 is not. There's ground, so that is ground, and pin 2 is hooked up to ground, and pin 2 actually goes to pin 9 on the CIA chip. 7, 8, 9. So pin 9 is shorted to ground. That's not correct. So here's pin 2. It comes from data out, pin 2, so it should definitely not be connected to ground. I checked on another Commodore 64 and definitely pin 9 on the CIA2 is not shorted to ground on that machine. Oh, I just checked. I removed all the testing harness stuff and then it was not grounded, so it's actually this serial loopback dongle here that connects it to ground, so that probably is correct then. Or not so fast. This is the other machine and I have now inserted the loopback adapter into this, and it is it's not shorted to ground. Even if the loopback adapter is. Pin 1 is ground and pin 9 is not. Yeah, so there is something there. I wonder if there's something wrong with this contact because it's kind of hard to get it in. You have to push really hard. So pin 2 on this serial connector is ground. So, and you have this shielding. Pin 2. Oh, there's something wrong there, yeah. You see both this pin and this pin is ground. And for the serial connector, you see only pin 2 is grounded, so I'm not really sure about the pin layout and numbering on that contact, but I can figure that out. What is connected to ground then? This is connected to ground. It should definitely not be, because this is also connected to ground. So is it because of the contact, or is it something else that's shorted here that connects those two? Definitely that's not correct. I checked the other machine as well. It's only one pin that is connected to ground in this unconnected state. Even so, there's a lot of components connected up from this chip via this chip to the serial port, and since these two are shorted together, and yeah, 0.5 ohms, then my only choice then is to try and desolder this, see if that releases that short. Alright, so I'm going to desolder the serial port, but when I look more closely here, I see something here. Can you see it? There's a trace there that is black, like it has been burnt. I'm going to zoom in. Maybe not the best lighting, but this trace that goes from one of the pins on the serial port, it's all black all the way here. So I think maybe there's a short that produces some heat, but the trace is not broken, so it's only the solder, the mask, that is black. So these connectors, they have really thick pins, so they're not the easiest ones to desolder. Let's see if we can do it with the desoldering station. Yeah, that works. I think that's it. It's loose. Yeah. Yes. Okay, let's see now. Did that release the short? No, it did not. Okay, so it's not the connector that's shorted out here. Connector is good. So I'm just going to clean up here, and I can in fact just solder it back again. I'm going to wait a little bit with that until I figure out something else. But why is that trace there black? I removed that black solder mask. This exposed the copper, and there's no break. But I'm gonna strengthen it with a little bit of solder. And it does not touch the neighboring traces. But we still have that short. Just gonna protect that trace with a little solder mask. It actually got loose some places because of the heat, I guess. To cure that, you need UV light. I have a little UV flashlight here. Takes a couple of minutes. Yes, now this is hard. Alright, this could obviously have been fixed with a wire. It would have been easy, but this looks better, I think. Alright, so I'm gonna hunt for that short, see where it comes from. So I traced the traces. This pin here goes directly to ground, so that's okay, but this one here should not be to ground, and yeah, I follow it here, and it goes up on that side, and it goes down a couple of times and up, and then it actually ends up with this capacitor. And yeah, I think maybe that is the culprit here, because if that side of the capacitor is grounded, then this should definitely not be, but it is. So this capacitor is shorted. Maybe. Could still be something else, but definitely it's a short there, and the other two are not. So okay, gonna solder it out. So I was trying to find the capacitor on the schematics, but it's impossible to read, so yeah, I can't find it. And if I take a look at other schematics for other variants, then it's different labels, so they are a bit different. Anyway, that doesn't matter, the cap is going out anyway. So I think I never experienced a ceramic capacitor like this has gone bad, but as I said, it can still be something else. Wow, that one just broke in 2 pieces. And that is 471. I didn't have the exact value, 470 picofarad, but I have these 220 picofarad. I think that's close enough. Moving on then, there is nothing wrong up until this point here, but it is still connected to ground there, so then it must be something further along here. And that trace goes where? I need to magnify. Yeah, it goes further on here and under this chip, but it's not connected to any of the pins. Just probing around the chips and see if any of the pins are connected to ground. There should only be one pin. Pin 1 is ground. And on this socket there was none, but on this one, pin 24 is connected to ground. And that is the flag pin on the pinout. And the flag pin on CIA1 is in fact connected to the line that is in question here, that is shorted to ground, so that makes sense. Doesn't mean that there's anything wrong here, but that line also goes to the cassette circuitry. If I take a look at the schematics, here's flag pin 24 on U1, and it goes up to cassette read. But it also goes via a diode here up to plus 5 volt and one diode down to ground. And it goes there, over there to the cassette, but it also goes over there all the way here. Yeah, this is the cassette interface. So it's a direct connection, and it has a couple of capacitors here. C151, C151. Well, that's the capacitor we just replaced. So that was where it was hiding. Okay, so this is good then, nothing there. What else can be connected to ground? Nothing else except these diodes. CR9 and 12. Okay, CR9 and 12 here. Need to check those then. Here CR9 and 12. Do we have a short here? No, that's the other way around. Alright, we have a short over that diode and not that one. But it could still be a short from somewhere else, but yeah, Just gonna remove that and see if that releases the short. The schematic doesn't tell what kind of diode it is, but it looks like a rather standard one. Hopefully I can replace it with some other diode if it's broken. So this is the diode. Let's see if I can try to read from zooming in what type it is. No, I can't. Anyway, did that release the short? Yes. Finally. Yeah, that's not connected to ground anymore. It is there, that's correct, but not to ground. Great, we found it. Now I just need to find a diode. And if we use a diode test on the multimeter, yeah, you see, it's completely shorted, at least that direction. Let's try the other. Yeah, it's shorted out both ways. I zoomed in on the phone and I could read 1N or N1 and 18, I think. So that's 1N914. Do I have the correct? It's not the Zener. It's impossible to read the values. I think the original one said 1N81 and yeah, this is 1N91.4. So I think this is close enough. I'm gonna use this, check if it works or not. Not sure how accurate these values need to be with the voltage drop. And I mean, the worst thing that can happen is that it breaks down and yeah, shorts out again. New diode is in. Okay, at least we don't have a short anymore. We have there, not there, but we have there. So that's correct. Let's test. So I feel optimistic now. Yes, yes, yes. That was it. A little diode. Okay. Damn, little diode, you made a lot of work for me. Okay. But now everything is okay, so I forgive you, little diode. So let me check with the original CIA chip that was in the machine, not the one I found from another. This one. Very short legs on this, but seems to hold up in those sockets anyway. Yay! Nice. Both CIA chips are fine. Okay. The machine is apparently fixed. I'm gonna let it run for a while and yes, I'm gonna check that diode, see if it gets hot, but it's not. So a small diode can short out and then it can bring signals down to ground, or it maybe even can bring signals up to short out the 5-volt rail and the ground, and that would be disastrous. And as you saw, it was almost burnt out one trace, so yeah, things can happen. On this machine too, I'm gonna use a couple of heat sinks on the chips that get warm. It's the next day and the board was running for 2 or 3 hours yesterday and no issues detected. Yeah, let's assemble the machine now and put it through some real testing. I noticed that one of the screw standoffs were broken off. Just gonna glue that in first with some super glue. This metal bracket for the keyboard, it has a couple of rust stains. Just gonna remove them and use a little WD-40 to protect. Well, let's see now if it can handle a heat sink under the keyboard. Looks like it's gonna fit. Yes. Keyboard is all the way down. Strangely enough, there was no heatsink from before, from the shield, as there usually is. Alright, it's finished and it's looking great. I had the keyboard outside in the sun for a few hours. I think it removed some of the yellowing. It was quite yellow on the sides, on the top. Hard to tell. Let's see now, does it still work? Yes, it does. And the keyboard, my new 3D printed key. I found some keys on eBay. I'm gonna order one if I find this particular key. Yeah, and the keyboard works very nicely. I'm barely touching the keys. Shift lock, yeah, shift, yeah, shift, space, run, stop. That loaded. So I'm going to test the real cassette drive and see if it works. So that little diode, it took down both the cassette and the serial port disk drives and everything. But now it should be fixed. Yeah, it found turtles. It loaded through at least, so that works fine. Now let's check out the disk drive. I have this one, it's a clone 1541 drive. So let's load the directory. Oops, device not present. Maybe it's set to 9. Yes. Alright, so here we have some games. Looks like some smaller unknown games. But it worked. Duck shot. Yeah, looks like a simple game. Quite easy. Anyway, the machine works perfectly fine. So another Commodore 64 saved from e-waste or its death or whatever. So it was a simple fix, but it was not easy to find. I don't know about that 7406 chip, if it was actually faulty or not, but at least now it's a new one. So great machine and great looking now and 100% working. Well, thanks a lot for watching. Hope you enjoyed this video, hope you learned something. And as usual, thanks a lot to my patrons and supporters, members. Thanks for your likes and your subscribes. See you next time. Bye bye.